This data was originally a part of UCI Machine Learning Repository. There are 506 samples and 13 feature variables in this dataset. So first we will import the libraries, the NumPy, Pandas and Matplotlib. Then we'll import the CSV file using pd.readcsv, and then we'll import our .csv file. Then we'll use the .head function to display the the first 5 rows of the data. Data.head displays the first 5 rows. Then we'll do data pre-processing by changing 0 values to null. So now we'll observe our data set. As in our data set, we can see the CHAS column and ZN column have most of the values are 0. So we'll change these values to null using .replace. The 0 is replaced with np.nan, which is null, and same as we'll replace the CHAS column. By using isNull, we'll calculate the percentage of null values. As we can see, the ZN column and the CHAS column has 73% and 93% null values. So we'll be dropping them. The ZN column is the proportion of residential land zoned for a lot of 100, and then the CHAS is Charles River dummy variable. So we'll be dropping these both columns using data.drop. Plotting a graph between x and y variables, which is data.crim and data.medv, and putting the x label as crime rate and the y label as price of the house, and then the title of the graph is crime rate versus the price of the house, and then we'll plot it using the plot method. Then we can see the graph here. So as you can see, as the crime rate increases, the rate of the house also decreases. As we look from left to right, the crime rate increases and the rate of the house decreases as the rate of the house decreases. So next we'll plot a bar graph using x as data.indus and data.medv as y. Then we'll put x label as non-retail business proportion and the y label as price of house, and then we'll name the graph as non-retail business proportion versus price of the house. And then we'll plot another graph which is data.nox and data.medv. Then put the x label as nitric oxide concentration and y label as price of the house. Then we'll plot. As you can see, as the nitric oxide concentration in this graph increases, the rate of the house also decreases. As the nitric oxide concentration is decreasing, the rate of the house is also decreasing. Now we'll plot another graph using x as data.rm and y as data.medv, where rm, as we can see, is average number of rooms per dwelling, and medv is the median value of the owner occupied homes. It is the median value. So now as we plot the graph, we can see as the average number of rooms are increasing, the price of the house is also increasing. Now we'll plot the another graph where x is PT ratio and y is MEDV. You can look that PT ratio is pupil teacher ratio by town, and that is MEDV is the median value of the owner purchased houses. This is how see that the graph is. Next we'll plot with x as data.lstat and y as data.medv. Lstat is the percentage of lower status of the population, and MEDV is the median value of the owner occupied homes. So as we can see, where there is the as the percentage of the lower status of the population increases, the price of the house also decreases. So as the lower status population is increasing in a percentage, the price of the house is also decreasing.